I'm waiting on Linda to give me a piece of paper.
Wait, you say graph?
Alright guys, so our steps
It's okay.
for graphing polynomials. I am going to ask you to list out some information before you start drawing the graph. On a test or quiz, I will prompt you, so I'm not just going to say graph it and expect you to remember all the things that you want to list. I will make it, okay, part A, tell me this, part B, tell me this, part C, tell me this, and then I'll ask you to draw the graph at the end, so you will know what things you have to do. When we graph, the first thing that we will always do is find the end behavior, which is something that we were doing before, so that is not new. That's the 2 arrows. Then I'm going to ask you to find all zeros and multiplicities. Okay, we were finding all zeros yesterday, so we know how to do that. Third step is tell if the graph.
Wait, you said if or is?
Sorry, I said if. Goes through or bounces at each 0. And what's that based off of?
Multiplicity.
The multiplicity. Remember, even multiplicities bounce, odd multiplicities go through. Step 4 is to get the y-intercept. Step 5 is to plot all information and graph. So these are the things that I will be asking you to do when we draw these graphs. Any questions there?
Okay. Mr. Argold, if you have a dead student in here, you know why.
It's a little light.
I mean, to be fair, okay, so let's take a look at this one. I want to draw this graph by hand. Now, I'm not taking your calculator away from you. You can use it to check, but you have to, when I'm looking at these, I'm checking every step along the way, and I'm checking that your graph matches all the information you wrote down. So you need to actually work it out. Use the graphing calculator as a tool to double check yourself. Don't try to use that to get your final answer. So, first thing I told you we need to find is the end behavior. A lot of times I might ask you to tell me the degree first, just because it helps with the end behavior. What would the degree of this be?
Down.
293. Tuition.
1. Oh, wait.
It would be an x cubed, right? So the degree is 3. So what would the end behavior be?
Down.
You know, a cube, there's no name in front flipping it, so it's going to be down up. So I already know a little bit about what my graph looks like. Okay, so next thing I want are the zeros. How do we find the zeros from this? That each of these equal to 0. Okay, you may or may not have to show any work there. I'm just writing this down so you can see what I'm doing. So my zeros are positive 1/2, negative 1, and negative 3. Okay, all of those have a multiplicity of 1. If it's a multiplicity of 1, you don't have to write that. If it's anything beyond 1, you do. Again, how do I know when I have a multiplicity?
Square.
Exponent, a square, a cube, something like that. The next question, does the graph go through or bounce?
Through.
All of these have a multiplicity of 1, so the graph will go through all of those when I draw it. Next step, y-intercept. What is a y-intercept?
When it crosses the y-axis.
What's x equal to if you're crossing? Okay, so you plug in a 0 for all of your x's.
Wouldn't it be the same thing in zeros?
On zeros, we set each one equal to 0.
Oh, yeah.
We set the y equal to 0. So we get negative.
1 and 3.
So my y-intercept is negative 3.
Yeah, how did you just pull that up? Oh, never mind. She's supposed to apply the negative 1 and the
I
1.
forgot what
She
negative.
just made the 1 y-intercept.
So my graph. Zeros are where we hit the x-axis. So I'm going to hit my x-axis at negative 3, negative 1, and positive 1/2. I hit my y-axis at negative 3. So I will check. You found those, you better plot them. Alright, my end behavior, my graph should start down here and end up here. We know this is a nice smooth curve. These are the only points where you can hit an axis. So we have to start down here. We hit this, we said we'd go through all of them. So we're going to go through, we have to turn around and come back and hit this one. Go through, come back, hit your y-intercept, hit your other one, and keep going through. So our final graph should look something like this. Double check, it matches the end behavior. The only place I hit my x-axis were those zeros. The only place I hit my y-axis was my y-intercept. So this should be good. How can you double check yourself? Grab a graphing calculator. Now, is my graph perfect?
Yes.
No.
Your graph looks amazing.
Well, I mean, I'm
Where's that?
pretty close to perfect. But for all I know, it may have went way up and way back down or something like that. I'm not worried about that on your graphs. I'm checking the zeros in behavior, those things. Okay, so double check your calculator, make sure the shape matches. Make sure when you're drawing these, they are curves. So I don't want zigzags. Okay, it is a nice smooth curve the whole time. Any questions on that
What
one?
in domain and range?
What number's got?
No.
I mean, you could.
No, good look.
Why would you ask a stupid question?
Well, because when we do it, bro.
Yeah, but,
What would the domain and range be for both
All
of these?
numbers.
75.
75 plus 20 equals greater than
Square
3.
root of 7.
Let's look at this problem.
That was mathematically correct,
Was it?
and you know it. If you break it down to like now algebraic, like
Use me.
then you do it and go over the numbers. What you would have missed, the snuck in the greater than infinity to positive infinity.
Alright.
Okay, you can just shut up.
Stop talking now.
Friday. Had enough of you already.
All right. If I were to multiply this all out, what would my degree be? 5, because we have 2 x's here and 3 here, so altogether the degree is 5. So what's the end behavior?
Down up.
4.
Jerry, give me some time. Hold on. Oh no.
Oh, it's up. Don't
Friday, I've had enough of you today. You know what? Can I sit with Ryan today?
Absolutely.
No, it's the memory of gauge.
All right, so zeros. What would make x minus 1 equal 0? What, just 1. And since it's squared, I would put multiplicity of 2.
1.
What makes x plus 2 equal 0?
Negative.
Multiplicity would be
3.
Wow.
One's a through and one's a bounce.
so at 1, the multiplicity was 2, so what will this one do?
3.
Bounce.
Bounce, that's what I said.
I heard balance off.
You're looking at the multiplicity itself. Even bounces, odd goes through. So when I look at the -2, this one will go through. Bless you. Y-intercept, if I put in 0 for all of my x's, 0 minus 1 is -1 squared. 0 plus 2 is 2 cubed. I get 1 times 8, which is 8.
Do we have to show that y-intercept?
As long as you have it, you don't really have to show the work. Okay. All right, so my zeros, that's where I hit my x-axis. That should happen at +1 and -2.
Oh.
I should hit my y-axis at 8. I'm going to count by 2s. If you count by something other than 1, that's fine, but please label.
Get a label.
Well, I showed that one with 8. So close enough.
No.
No,
I'm confused now.
I'm not.
My graph
Because the one, never mind. It's good.
is supposed to start down here and end up here. So I'm starting from the bottom. At -2, my graph goes through. So we have to go through this point, hit the y-intercept, come back down and hit 1, and at 1 my graph bounces. When it bounces, when you have a bounce, it's not making a V, okay, it's like a U. So it should look something like this.
Yeah. Alright, flip my page. Wrap it up.
Alright. You guys want to try one?
Yeah. Sure. First next one.
Let's kind of check.
I don't even know how we get a y-intercept. So.
Degree. So you count your x's. We have 5 here, 1 here, and 4 here. So 5 plus 1 plus 4 is 10. End behavior, since it's even and positive, both ends are pointing up. Zeros. Alright, if you set this equal to 0, anytime you have a plain x, it's just 0. And it would be multiplicity 5. If you set x minus 3 equal to 0, you get 3. If you set x plus 4 equal to 0, -4, multiplicity 4. Wait a minute. You're
Yeah.
saying you didn't know how to do this, but you won't quit talking.
No, I'm already know that part.
Such a trap.
So, now we need to go through or back.
Dang.
All right.
This whole time, don't even get all of them.
Multiplicity of 5. 5 is odd, so it goes through. All right. 3 is just a multiplicity of 1. 1 is odd, so we go through. -4, multiplicity of 4. So 4 is even, so that one will bounce. Y-intercept. You plug in 0 for all of your x's,
It's gonna be 0.
and you get 0. If on any of these you get a really large or really small y-intercept, I am okay with you just labeling it. So if you had gotten 256, you know, you could just draw a line and label it 256. I'm not going to make you count all of that. Okay, so now to wrap this. So my zeros, we hit the x-axis at 0, 3, -4. Both ends should be pointing up. We hit the y-axis at 0. So I'm going to come down. I hit this first 0, and what does my graph do at -4? Bounces. So it's going to come back up. At some point, we've got to come back and hit the next one. My graph's a little bit off there. Come back and hit here, and it goes through. We have to turn around and come back and hit the last one, and it goes through. So my graph looks something like this.
Yeah. Or I want to, like you want to do.
Okay. We are going to do one last problem together.
Okay.
I can believe it.
different.
It's not factored.
It's not factored. Okay, so that makes it easier to get the degree in behavior. Degree is 3. If it's not in factored form, you just look at the highest power. In behavior, because of that negative,
Up, down.
up, down.
Up, down.
All right, zeros. A little bit harder to find because it's not factored. So we have to think about factoring this. Okay,
Not me, bro.
could we take out an x?
Yeah.
And since first one's negative, let's just take out negative x.
I mean, I don't know.
What'd you have to do for that?
Slip.
Slip and slide.
Slip it and slide.
Not really, that's two,
Okay, so multiply the negative 2 and add to positive 1. Bx plus 2, x minus 1,
Divide by 2.
divided by 2. So we get x plus 1, 2x minus 1, and what else do I need? The negative x that I pulled out before. So that's my factored form. So what are my zeros? Just anytime you have an x by itself, it's a 0. All of these have a multiplicity of 1. So what's going to happen? Yep, cross or through all of them. Y-intercept. If you plug in 0 for x, you can do that in your factored form or the original. It does not matter.
A 0.
We get 0. So, hit the x-axis at 0, negative 1, positive 1/2. Y-axis at 0. It should start up here and end down here.
Isn't it down?
No.
Because it's
No.
odd degree.
Oh.
So, it'll come down, hit the first, and we said it's going to go through. Come back and hit the next one, goes through. So something like this. Any questions for me?
No. Alright, so no homework today, guys.
So there is a handout posted, and you've got about 25 minutes or so, 20 minutes or so to work on that right now.
Right.